So, your application is a hit. That's awesome. Traffic is soaring, users are loving it, but your database, well, it's starting to sweat a little. It's slowing down, it's struggling to keep up with all the read requests. This is a classic growing pain, and it brings up a huge question. How do you scale your reads without just throwing more and more money at a bigger, beefier database? So, in this explainer, we're going to tackle that exact problem head-on. We'll kick things off by really defining what that read bottleneck is. Then we'll look at the two main paths you can take to scale. We'll put them in the ring for a head-to-head showdown, take a peek under the hood at how caching actually works, and finally, give you a solid framework for making the right call for your app. Let's dive in. Okay, first things first, let's talk about the core problem. The read bottleneck. It's what happens when your main database, which has to juggle both writing new data and reading existing data, just gets totally overwhelmed by the sheer number of read requests. Does this sound familiar? Pages take just a little bit longer to load, API responses start timing out, and that slick user experience you built starts to feel sluggish. And this isn't just a tech headache. A slow site can cause something like 90% of users to just give up and leave. This is the classic sign that your database is spending way too much time just serving up reads. And hey, this is not a theoretical problem. This quote right here from a developer on Stack Overflow, it just hits the nail on the head. They've hit a performance wall and are looking for a smarter way to scale than just making their main database bigger and, way more expensive. So what are the options? So, how do we solve this? Well, there are two main contenders for taking that intense read traffic off your primary database. Let's introduce them and see how they stack up. This right here, this is the before picture. It's pretty standard. You've got your application servers, your EC2 instances, and they're all talking directly to one primary database. Every single request, doesn't matter if it's writing a new comment or reading an old post, it all hits this one central point. It's simple for sure, but it's also a perfect recipe for a bottleneck. Okay, so here are our two distinct strategies. The first idea is to create an exact copy of your database called a read replica, just for handling read queries. The second idea is to bring in a whole new layer, a super fast in-memory cache, like Amazon ElastiCache. Both of them are trying to do the same thing, reduce the load on the master, but they go about it in totally different ways. All right, let's do this. It's time to put these two solutions head to head. We're going to compare them across the things that really, really matter when you're building a high-performance application. First up, let's talk about how fresh the data is. A read replica is almost always in sync with the master database. We're talking a lag of maybe a few seconds, tops. It's all about consistency. ElastiCache, on the other hand, holds a snapshot of data from a moment in time. This means the data might be a little stale. So the trade-off you gotta ask yourself is, does my user need the data from this exact microsecond, or is data from a few minutes ago totally fine? Next, performance. And whoa, this is where the difference is just dramatic. A read replica, remember, is still a database. It reads data from a disk, which gives you responses in milliseconds, which is fast. But ElastiCache is an in-memory service. It reads data straight from RAM. That is orders of magnitude faster, giving you responses in microseconds. This really gets to the heart of it. We're talking disk versus memory. Just how much faster are we talking? Well, for those really read-heavy applications, AWS claims that using ElastiCache can be up to 80 times faster. Now, to put that in perspective, that's the difference between a page loading instantly versus you having just enough time to notice it's loading, maybe even take a sip of your coffee. It is a huge leap that can totally change how responsive your application feels. Okay, what about the kinds of queries they can handle? A read replica is a full-blown database. You can throw any complex, dynamic, wild SQL query you can think of at it. That makes it perfect for stuff like analytics or reporting dashboards. ElastiCache, it shines at something different. High-volume, repetitive queries for the same chunks of data, what we call hotspots. Think of a celebrity's profile page or the details of a best-selling product that everyone is looking at. And finally, let's talk money. Now, this might seem a little backwards, but adding a caching layer can actually lower your overall database costs. Seriously. As you can see here, by offloading most of those reads to the cache, you avoid the super high cost of scaling up your main database. And you could potentially see your overall costs drop by as much as 55%. So, we've established that caching is incredibly fast. But how does an application actually use a cache? Let's look at the most common and, honestly, the most straightforward strategy. It's called the lazy loading or cache aside pattern.
The core idea behind lazy loading is super simple. You only load data into the cache when it's actually needed. This does mean your application's code is now in charge of managing the cache. The only tiny downside is that the very first time a piece of data is requested, you get a cache miss, which is a little bit slower. But every single request after that for the same data, lightning fast.
Let's just walk through the logic here. First, your app needs some data. It immediately looks in ElastiCache. If the data is there, boom, that's a cache hit. It's returned instantly. Super fast, super efficient. But if the data is not in the cache, that's a cache miss. The app then goes and queries the main database, just like it used to. But, and this is the key step, before it sends the data back to the user, it first writes that result into ElastiCache. That way, the next time that same data is requested, it'll be a cache hit. And this is what that after architecture looks like. You can see the ElastiCache tier now sits right between the application and the database. It acts like a high-speed buffer. And it doesn't matter if you use an engine like Memcached, which is great for simple key-value stuff, or Redis, which has more advanced features. The principle is exactly the same. Intercept those frequent read requests and serve them from memory, protecting your database from the traffic storm. Woo! We have covered a lot of ground. So now let's pull all this information together into a really clear decision framework to help you pick the right path for your specific needs. Okay, this slide right here is your cheat sheet. Let's run through it. First, data freshness. If you need near real-time, up-to-the-second data, a read replica is your answer. But if slightly stale data is okay, ElastiCache is perfect. Next up, performance. If millisecond latency is good enough for your app, stick with a replica. If you need that extreme microsecond level speed, it's gotta be ElastiCache. Now what about your query patterns? For complex, ever-changing queries, a replica is the way to go. But if you have those hotspots getting hit by the same simple queries over and over, that's a job for ElastiCache. And finally, what's your primary goal? If it's to offload heavy analytics and reporting, choose a replica. If it's to maximize app speed and cut your database costs, choose ElastiCache. So why does making the right choice here matter so much? Because it translates directly into real-world benefits. You get a faster, much snappier user experience. You can actually achieve lower operational costs. Your application becomes way more resilient, and maybe most importantly, you have a buffer that protects your database from those sudden, massive spikes in traffic. So, by understanding these two different patterns, you've learned how to intelligently offload traffic and really scale your application's read performance to handle pretty much any load, all while keeping things fast and cost-effective. But, solving the read bottleneck, that's really only half the story. You've made your reads lightning fast, which is fantastic, but as your application keeps growing, a whole new challenge is going to start to emerge. What happens when you need to scale your writes? Well, that's a different problem with a whole different set of solutions.